acceleration relative to its reference point. So for example, if I roll this and I'm the reference point, it's in motion.
The amount of total change of position over the course of a motion is called distance. In other words, the length from start to finish. Distance is a scalar quantity. A scalar quantity has magnitude but no specific direction.
Displacement is a vector quantity, which has both magnitude and no specific direction. Displacement is the overall change of position from start to finish.
The distance an object travels per unit of time is called speed. Speed is a scalar quantity. Speed in a specific direction is called velocity. Velocity is a vector quantity.
When an object speeds up, slows down, or changes direction is called acceleration.
All of these things relate to one-dimensional motion. It is referred to as one-dimensional because it is motion that moves along in a line.
Speed, velocity, and time can be put into graphs called motion graphs. Motion graphs are represented by distance over time and velocity over time. Motion graphs always have time on the x-axis.
The slope of a distance over time graph equals velocity. In distance over time graphs, a horizontal line means that the object is at rest. A straight diagonal line, a gradually sloped line, or a steeply sloped line can represent constant positive velocity or constant negative velocity. A curved line on a distance over time graph represents constant positive acceleration or constant negative acceleration. The slope of a velocity over time graph equals acceleration. A horizontal line on a velocity over time graph can represent constant positive or constant negative velocity, or an object at rest, depending on where the line is located on the graph. In velocity over time graphs, a straight diagonal line, a gradually sloped line, and a steeply sloped line represent constant positive acceleration or constant negative acceleration.
The slope of a line mathematically represents the relationship between two variables. It is calculated by the change in y over the change in x. For example, on a distance over time graph, if your distance goes from 8 to 4 meters and your time goes from 4 to 2 seconds, then your slope is equal to 2. There are also equations to calculate acceleration, velocity, and speed. The equation for speed is distance divided by time, measured in meters per second. The equation for velocity is displacement divided by time, also measured in meters per second. And the equation for acceleration is the final velocity minus the initial velocity divided by time. Acceleration is measured in meters per second squared.